Hello, students. All right, I'm going to need you guys to have out your packet, your calculator, and I want you to get started on the do first. We're going to go over the do first in just a second. So take the time to do the do first, and we'll go over it in just a second. All right, so yesterday you guys learned about electric field diagrams. The question asked, do the two charges have the same charge or are they opposite charged? And to label them positive or negative on the diagram. So the key here is, which direction are the arrows pointing? From the charge on top, they are pointing out, which means it's a positive charge. And from the charge on bottom, they are pointed in, which means that it is a negative charge. There you go. Let's get on to today's lesson. So we're going to talk about calculating with electric fields. So the question I want to bring up in everyone's mind is, what information do the electric fields give us? Look back through your notes from yesterday. What information do we get from an electric field? The information that we get from an electric field is that they tell us what force a particle would feel at a specific point, specifically what force a positive particle would feel at a specific point. So actually, electric field has an equation. This is it. Go ahead and copy that down. The letter E stands for electric field. The letter F stands for electric force divided by little q, which is charge. That is the charge which is placed inside of the field. Another way of rearranging this formula is F equals EQ. Just as a reminder, electric field is a vector. Remember, because it can either have an arrow pointing outward or inward, that lets you know it has a direction. The units for electric field are newtons divided by coulombs. So there's only one example, so make sure that you get this one example. The electric field at a certain point in space is 10 newtons per coulomb north. What force would a positive 7 coulomb charge feel? So, well, how about this? How about it's asking for force, so F equals E times Q. So then F equals 10 newtons per coulomb times 7, which is 70 newtons. Let's talk about direction. So if the field is north, and an electric field tells you the direction a positive charge would feel a force, then the force will be north because it is a positive charge. Next part of the example. What force would a negative 0.9 coulomb charge feel in this 10 newtons per coulomb north field? Well, force again equals E times Q. So that is 10 newtons per coulomb times 0.9 coulombs, which is 9 newtons. All right, and another thing to note is that it is a negative charge. Therefore, the force will be the opposite of the field. So if the field is north, then the force is south. And the next question is, what force would an electron feel? Well, electron. An electron is the charged particle, so do we know what the charge of an electron is? Okay, well, it turns out that according to Google, the charge of one electron is 1.6 times 10 to the negative 19 coulombs. So 1.6 times 10 to the negative 19. So that's saying that in an electron, that is, Q equals 1.6 times 10 to the negative 19 coulombs. So the force will equal E times Q. So that is 10 newtons per coulomb times 1.9 times 1.6 to the negative 19, which is 1.6 times 10 to the negative 18 newtons. And let's talk about direction. Electrons have a negative charge. Therefore, the force will be south. Well, that is the end of the lesson for today. So you guys have practice. Just remember that on Wednesday, you'll be taking an exit ticket over electric fields. That's going to include electric field diagrams and the electric field formula. The electric field formula being E equals F over Q or F equals EQ. So make sure that you finish all your practice problems. Good luck, and I will see you guys on Thursday.